Well, ladies and gentlemen, you would all agree with me that the importance of sponsors is a very vital aspect towards the success of any event or any endeavor. At this juncture, I would request the SVP and CTO of Applied Materials Incorporated, thanking him for being the platinum sponsor and to address all of us. Ladies and gentlemen, swagat kijiye Dr. Om Nalamasu. Please welcome Dr. Om Nalamasu.
Good morning. I was taking notes in the morning while I was listening to different presentations. And what I'm going to talk about resonates with some of the messages I have heard. I heard from Subrato the idea of inflection and how do you season the inflection, and how do you build scale, and how do you do arbitraging maneuvers, I guess we call it escape velocity. And talked about the passion of individuals in making things happen, specifically talked about two individuals who were behind the IT revolution in India. Sanjeev's presentation outlines three audacious goals as we think about future. 50 fabulous startups, 2 million jobs over a 5-year time period, and 50% local manufacturing. And the minister talked about the Karnataka state-specific semiconductor policy and certainly came up with some goodies. What I like to do today is resonate with the theme of consumption to creation, and many of the messages I'm going to talk about have been articulated very well by IESA over the years. Just give some color to that. And I also want to talk about my own personal experiences, having spent quite a bit of my career back at Bell Labs, which in some ways catalyzed ecosystems elsewhere. And I spent 6 years in the capital district of New York State. That's where Albany Nanotech was created. So some of the things I learned about the difference between a viable semiconductor ecosystem versus a sustainable ecosystem in the semiconductor industry. So those are some of the things that I want to talk about today. So before that, I want to go do a little commercial about Applied Materials. I think most of you know Applied Materials, but I do run into people who ask me how is AMD doing and how is Advanced Materials doing. So just to set the record straight, I work for Applied Materials. We are a 47-year-old company based in Silicon Valley, and our revenue hovers around $7 to $10 billion. And a point I would make later on as well, this is an R&D intensive industry. So we invest $1 to $1.4 billion a year. Last year happens to be $1.3 billion. And we take pride in working with our customers wherever they are in the world. So that's why we have locations in 85 places across 18 countries. We have a very large presence in India. In fact, 2 years ago, we had a 10th anniversary. We started with about 2 people, and today it is about 2,300 employees. So a big success story, and Indian engineering plays a critical role in every product we design and every product we make. We also take a great deal of pride in working with Indian academic institutions. We have a very strong collaborative program with IIT Bombay over the last 7 years. And we have made capital donations to the tune of 75 crores over the last 6 years, and have 20, 30 people working actually on IIT Bombay premises, collaborating with the faculty, collaborating with the students. I was recently at Washington University with IIT Bombay team, and Mark Wrighton, the chancellor of the university, was saying this is a gold standard by any standard when it comes to an industry and university collaborating in such an intimate way. So enough of that, but what I want to do today is basically talk about the consumption drivers that mandate that India be a semiconductor player, India have semiconductor fabs, and specifically talk about Indian opportunity, the idea of frugal innovation. While you're developing products that are strategic to India's interest, how you could tailor them with value additions in competing in the global markets. And on the demand side, basically, you need to come up with a sustainable ecosystem so you have products and services that are competitive across the globes, and then I would tie it all together. So let's first talk about the drivers. And so this is the age of mobility, as you all recognize. And if you look at last 5 or 6 years, cumulatively, mobility has contributed about $1.2 trillion to the electronics ecosystem globally. The projected value of the electronics ecosystem in 2014 is about $1.6 trillion. So roughly of the same magnitude you're talking about over the 4 to 5 years. And there is explosive growth, as you all know, in tablets and smartphones. And smartphones and tablets today are sold more than PCs. And those of you who are in consumer electronics show, you can actually see a great deal of innovation in this space. China is very big into this. They're selling tablets and smartphones, and there is a new category called phablets, basically a combination of tablet and smartphone. And in 2015 and 2016, it looks like tablets alone may dwarf the sales of PCs, and PCs obviously are redefining themselves. There is battle for market share, and certainly an ecosystem is being built. I think what is very exciting to me is the future the semiconductor industry is going to hold. There are 2 levels to be thinking about. Within the electronics industry itself, we are looking at Internet of Things. So we are transitioning from age of mobility to age of connectivity. So that is, of course, going to contribute even more to big data and cloud computing. The other theme at the Consumer Electronics Show was wearable devices, whether it is healthcare, whether it is exercise, Internet of Things. So you're looking at connected home or smart home, automotive industry, for example. So if you're looking at 2020, depending on which estimate you believe, there would be about 25 to 50 billion devices that are going to be connected, and the fundamentals of that, of course, are going to be based on the semiconductor technology and the electronics technology. Then there is the Indian angle. So today, 2014, United States constitutes about 4% of the population and consumes about 25% of the global resources. But if you're looking at future, China and India are going to have vibrant middle class, which is going to grow. And if you just look at 2030, India and China together would contribute 45% of the middle class, globally speaking. And their consumption is going to dictate the economies of the future. And India really can't afford to be behind. And its consumption is only going to be increasing, and unless you figure out a way of dealing with it, you're going to have import issues that the minister talked about. So let's talk about India opportunity specifically. Again, this is a point that has been made. Indian electronics market is growing at about 11% CAGR, and it's expected to go from 39 billion in 2010 to 65 billion in 2015. Consumer-driven electronics consumption is growing fairly strongly, and you have 5 devices on the view graphs that constitute majority of the electronics items sold in India. But 65% of the value of electronic products sold in the country is imported, and if you look at the value chain, there is zero manufacturing in India, whether it is the front end or the back end. And Indian electronic system itself is relatively small, but if you tie this to what is going to happen with the middle class and the growth in the coming years, this is the time to be thinking about it, coming up with the policies, so you are proactively addressing the issue that you're actually going to face. So this is where we want to make a point about the importance of manufacturing GDP relative to the real GDP. So there's more or less a straight line correlation. The size of the circle indicates the size of the economy related to manufacturing. So if you're looking at China, it's got about a $1.5 trillion manufacturing economy. If you look at India, it's probably about $250 billion manufacturing economy. So the manufacturing GDP is high, the real GDP is high. And a related point to be made is that if you look at China, if you went back to 1981, and between 1981 to 2010, China has lifted 680 million people out of poverty because of the manufacturing economy. And if you look at India in 1981, there were about 429 million people in poverty, and if you look at 2010, it is still 400 million people living in poverty. So if you want to lift people out of the poverty, you really need to be thinking about manufacturing economy and the associated trickle-down benefits. So how do you make a viable ecosystem for semiconductor manufacturing in India, and how do you make it sustainable is going to be the second part of the presentation. So it's wonderful that we are at an inflection point. We are going from a consumption economy to a creation economy, and certainly everybody is aware of the report that came in November 2013, and presumably the letter of intent would be signed in the next couple of weeks, and this vision would really become a reality, and everyone here knows about the two proposals that are pending with the Indian government, and both of them would have relatively state-of-the-art technology, not necessarily 18 or 22, but starting at about 90, 65, 45 nanometers, with a roadmap to going down to 22 nanometers. So there is a whole lot of discussion, I guess, in India about what is leading edge and what should India aspire to get with respect to technology. But leading edge is really device dependent. Other than for state-of-the-art memory, state-of-the-art processors, 45 nanometers is relatively leading edge for a variety of devices, and I just shown some examples there. So if you're looking at automotive, it's about 40 nanometer is a state-of-the-art. Display drivers, 55 nanometers. Power management, 130 nanometers. RF antennas, 180 nanometers or 130 nanometers. Amplifiers is about 180 nanometers. And of course, each one of these devices would have a chipset which combines different technologies to have a working device that does a certain function.